uh, in the last lecture of second order differential equation. So d2y by dx square plus p dy by dx plus qy is equal to r. We solve that equation when one integral is known, and we explain the method how to solving the differential equation when one integral is known, and taking one example on this by using that method. So we take one more example. So solve d2y by dx square minus cot x dy by dx minus 1 minus cot x y is equal to e raised to x into sin x. Okay, solve this example. Okay, solution. So we compare this differential equation with standard equation d2y by dx square plus p dy by dx plus qy is equal to r. So this is the second order differential equation. By comparing this equation with this, so what is p here? So p is equal to minus cot x What is q? Q is equal to, so what happened? Q is equal to this coefficient of y minus 1 plus cot x, and r is equal to this, r is equal to e raised to x sin x. Okay, so we find here p, q and r. So we take a rule, so that is 1 plus p plus q is equal to 1 p, that is minus cot x, plus q, so that is minus 1 plus cot x. So this is equal to what? 1 minus 1 get cancelled, minus cot x plus cot x get cancelled, so this is 0. If 1 plus p plus q is equal to 0, therefore u is equal to e raised to x is a known solution. Okay? Then now we put y is equal to uv. So what is u? So that is e raised to x into v, where v is the function of x. Okay? Therefore, putting y is equal to uv, find the derivative dy by dx. Again find the derivative d2y by dx square. And putting all those in this differential equation, we get, so that equation reduces to, so that is d2v by dx square. So by changing the dependent variable y to v, we get the equation. So this is p plus 2 upon u du by dx into dv by dx is equal to r upon u. Okay? So by putting y is equal to uv in this equation, we get this equation. So we discuss about that in the theory of the solving second order differential equation when one integral is known. So you remember this equation. So that is better here. Okay. So therefore, d2y by dx square plus, what is p? P is what? Minus cot x plus 2. What is u? U is e raised to x. And what is du by dx? So derivative of this, so that is e raised to x into dv by dx is equal to, what is r? R is e raised to x sin x divided by u is what? E raised to x. Okay? So therefore, this equation becomes here d2v by dx square, e raised to x get cancelled, so that is 2 minus cot x dv by dx is equal to e raised to x get cancelled, so this is sin x. So now putting dv by dx is equal to q, and taking derivative of this again with respect to x. Derivative of this is with respect to x, so that is d2v by dx square is equal to dq by dx. Okay, so putting these values in this equation, we get, so this equation reduces to, so that is what happened here. So d2v by dx square is dq by dx plus 2 minus cot x. 2 minus cot x. What is dv by dx is q, and this is sin x as it is here, sin x. So this is a first order linear differential equation of the type. So what happened here? So that is the dq by dx plus p dash q is equal to sin x. Something p dash, something q dash. Q dash. So we learn. So what is the first order differential equation? dq by dx plus p dash q dash. So what is the solution of the differential equation? This is the first order differential equation. Before that we have to find here integrating factor. Integrating factor. So that is e raised to integration of p dash dx. So this is equal to e raised to integration of what is p dash? 2 minus cot x dx. So therefore integration is what? So e raised to, what is the integration of 2 dx? So that is e raised to 2x. What is the integration of cot x? So minus log of sin x. Log of sin x. So this is equal to e raised to 2x into bracket e raised to minus, that is the log of, so this is minus, so sin x raised to minus 1, so that is 1 upon sin x, so that is the log of cosec x. So this equal to, okay, so this is the integrating factor. So therefore the solution is, so what is the solution of this differential equation, first order differential equation? So the q into, so what is the integrating factor? So what happened here? So that is, integrating factor is this, e raised to 2x, e raised to, just a minute, so this is what happened, e raised to 2x, e raised to log of cosec x is simply cosec x is equal to integration of this integrating factor e raised to 2x cosec x into q dash. Q dash is what? Into sin x dx plus integrating constant. So that is c1. Okay. So this equal to what? E raised to, so cosec x sin x get cancelled. Sin x. Cosec x sin x get cancelled. So that is e raised to 2x plus dx plus c1. So what is this? So that is e raised to 2x divided by 2 plus c1. So this equal to this here. So this can be written as e raised to 2x. So just put q is equal to dividing throughout by this e raised to 2x into cosec x, so that is q. So what happened here? E raised to 2x, e raised to x cancel. So 1 upon cosec x is the sin x divided by 2 plus what happened? So this is c1 into So dividing this to this, so that is sine x into e raised to minus 2x. Okay, e raised to minus 2x. So what is this? So this is the dv by dx. dv by dx is this sine x by 2 c1 sine x e raised to minus 2x. Okay, so that is a very simple one. Okay, so then dv by dx is this here. So now integration. So v is equal to integration of dv is v. What is integration of sine x divided by 2? So integration of sine x is cos x divided by 2. Sine x integration is minus cos x plus what happened? C1 e raised to minus 2x sine x dx plus C2. So what is the e raised to minus 2x integration of into sine x dx? So we know the formula integration of e raised to x into sine bx is equal to what? 1 upon a square plus b square into bracket a sine bx minus b cos bx. Okay, very simple. So find this integral here, e raised to minus 2x sine x dx. So what is a? A is minus 2. A is minus 2. What is b? B is coefficient of x, that is b is 1. B is 1. Putting those values in this formula, we get the solution of this integration here. So we get v is equal to minus cos x divided by 2. So putting the values of a and b, we get the solution. So that is C1 e raised to minus 2x divided by 5 into bracket. So that is minus 2 sine x minus cos x plus integrating constant C2. So this is the v here. So putting the value of u and v, what is u? U is e raised to x. U is e raised to x. What is v? V is this. Putting both values of u and v, we get the complete solution of the given differential equation. So we already known we have to find the known solution of the differential equation and then put v is equal to this here. So we get the complete solution of this differential equation. So very simple examples. You remember some formula here, then you solve easily that examples. Okay. So then we take here the another method of solving the second order differential equation by changing the dependent variable, means by removal of first order derivative. Okay. So next method, removal of first order derivative means changing of dependent variable. Why? We change dependent variable y in terms of v with particular substitution, then the first order derivative get removed and the equation becomes easy to solve. Okay, so then what is the method here? Let the equation d2y by dx square. So this is the second order differential equation p dy by dx plus qy is equal to r here. So this is the differential equation. Okay, so let's put y is equal to uv. Y is equal to uv. Then what is the derivative of this with respect to x? So dy by dx is equal to u dv by dx. U dv by dx. We discussed same in the last theory. So this is a very simple one. So again, differentiate this with respect to x. So this is the d2y by dx square is equal to u into d2v by dx square plus 2 times du by dx into dv by dx plus v into d2u by dx square. Putting these values d2y by dx square, dy by dx, y is equal to uv in this equation. Therefore, this equation becomes here. Therefore, this equation becomes, what is d2y by dx square? So this, u into d2v by dx square plus 2 du by dx into dv by dx plus v d2u by dx square plus p. What is dy by dx? Dy by dx is this, u dv by dx plus v du by dx, okay, plus q. What is y? Y is equal to uv is equal to r, okay. So this is the equation here. We write this equation in the form in terms of v u d2v by dx square, okay, plus we collect here in the bracket the coefficient of dv by dx, so that is pu, plus 2 upon 2 into du by dx into dv by dx and plus what is the coefficient of v? Coefficient of v is equal to r. So what is the coefficient of v? So that is coefficient of v. What happened here? So that is the d2u, coefficient of v, d2u by dx square. Again plus coefficient of v, again coefficient of v, v p into du by dx. This is the coefficient of v plus qu. Okay, so this is a very simple. After simplification we get this. Okay, so now dividing this equation by u, okay, dividing this equation by u, so we get 2 upon u, we get plus 1 upon u divided by u. So this is the equation number 1 and this is equation number 2. After putting the values of y is equal to uv, dy by dx, d2y by dx square in this equation, we get this equation. Okay, this equation. So what is the next method? So removal of first derivative by changing dependent. We change already dependent variable. Here is the dependent variable is v instead of y. So now we remove that first derivative. Then the equation becomes very simple. We remove that. Okay, this derivative, first order derivative. So for removing first order derivative, so the coefficient of dv by dx must be 0. If this is 0, then automatically this term get cancelled. Means the first derivative removed here. Okay, we find u. We find u such that the first order derivative removed. Derivative removed. That is the coefficient of dv by dx is 0. Okay. So what happened? So p plus 2 upon u du by dx is 0. Okay. So therefore, by variable separable type, so this is differential equation. So this becomes here du by u, and then this equal to minus p by 2 dx. Okay, dx. So multiplying this by dx, that is p dx, again divided by 2, and we get minus p by 2 dx. Okay, p is a function of x only, so variable are separate here. So on integration, so what is the integration of this? So this is log u minus p by 2 minus 1/2 integration p dx. So what is u? So we find here u is equal to minus half integration of p dx. So this is u. This is u. If we put u is this in this equation, u is this, put u is this in this equation, and putting all those values in this equation, then the first order derivative automatically removed here. Okay. So now du by dx, again differentiate this. So what happened? What is the derivative of this? Minus 1/2 integration of p dx. Okay. Into derivative of this is minus half into p. Okay. Derivative of the integration get cancel here. So that is very simple. So what is, I can find out d2 u by dx square. Taking derivative of this again. So then what happens? So this can be written as, so just a minute. So minus half p. What happened here? Minus. So just this can be written as, okay, minus 1/2. So that is p. What is this? This is u. So this is u. So differentiate this with respect to x. Again, we get d2u by dx square. So this is minus half. Okay. So that is p as it is. Derivative of u, du by dx, minus half u as it is. Derivative of p, dp by dx. Okay. So putting the values of du by dx. Du by dx is what? Du by dx is minus 1 of pu. In this equation what? Minus 1/2 p. So what is this? What is this? Du by dx is minus half pu minus 1/2 u dp by dx. dp by dx. Okay. Therefore, so what is this? This is minus half minus 1 by plus 1 by 4 minus half into 1 minus half 1 by 4. So that is p square u minus 1/2 u dp by dx, minus 1/2 u dp by dx. So what is this? This is d2u by dx square. Okay, very simple. d2u by dx square. With this value, so this value, and this value, putting those value in equation 2. So this becomes here. This becomes. So that is 1 upon u. So that is a d2u by only this part taking here. dx square plus p du by dx plus qu is equal to. So that is 1 by u. What is d2u by dx square? So that is 1 by 4 p square u minus 1 by 1/2 u dp by dx plus what is du? P plus p into du by dx. du by dx is this minus 1 half pu plus qu. Okay, so after simplification, so what happened here? So after so you get cancelled, you get cancelled, you get cancelled. So simplifies this. So this is q minus 1 by 4. Q is here. You get cancelled. 1 by 4 p square. Okay, this and get you cancel. P square minus 1 half you get cancelled dp by dx, and this is equal to q1c. Okay, so therefore the equation 2 becomes here. The equation 2 becomes, what happened? Equation 2 becomes, so what happened? d2v by dx square. d2v by dx square. Okay, this term is removed. First derivative is removed. So taking coefficient is 0. This is removed. Okay, plus what is this term? So this term is this. So this is q1 is equal to, and this is r1. This is r1. So what is the q1? q1 is what? So what is r1? r1 is equal to r upon u. What is q1? q1 is this. q1 is q minus 1 by 4 p square minus 1 half dp by dx. Okay, so this is the when we change the dependent variable y to v with the substitution y is equal to, so u is what here? So u is e raised to minus 1 half integration p dx, and v as it is. If we substitute this in this differential equation becomes like that, where q1 is this, r1 is this. So this is very simple differential equation to solve. So we can solve this differential equation easily. We get the required solution. Okay. So this is, and we have to find here the value of v. When we solve this differential equation, we get v. So we substitute v in this equation. We get the complete solution of the differential equation. In the next lecture, we are taking the example and solve those examples by using removal of first derivative method. Thank you.